Welcome to the first unit in the last, the first lesson in the last unit of AP Chem, and for some of you, your last unit ever. So this lesson is going to discuss the differences between ionic and covalent bonding and the difference in properties between ionic and covalent compounds. And it's going to be one of the shortest video lessons that we've ever done. So if we compare salt and sugar, so the chemical formula of salt is NaCl, and the chemical formula of sugar, this is glucose actually, is C6H12O6. Salt is an ionic compound, and sugar is a covalent compound. So here we're comparing the properties of salt and sugar, which so basically comparing the properties of an ionic compound with a covalent compound. So in a ionic compound, electrons are transferred from the metal to the non-metal. And in covalent bonding, electrons are shared, usually between nonmetals, or always between nonmetals, and sometimes semimetals. An ionic bond is always between a metal and a nonmetal, so that's how you can tell a bond is ionic, if you have a metal and a nonmetal. And covalent bonds, which are considered molecular, so you can only call covalent compounds molecules. Ionic compounds are not molecules, is always between a nonmetal and a nonmetal. And to be honest, on this slide, you should be writing everything I say. So I left space on the bottom for you to write a lot to explain. I'm going to explain what each one is as we go down further here. You should be writing all over this slide. So ionic compounds are electrolytes. So that means when you put them in water, they dissociate. And that allows them to, remember, conduct electricity, which we discussed in the last review session. Covalent compounds are non-electrolytes. The atoms do not dissociate in water. They stay together, so as a result, they do not conduct, or there's no conductivity when you put a covalent compound in water. Okay. Ionic compounds have extremely high melting points, okay? And the reason why, which we're going to talk about at the very end of this unit, is because ionic compounds have really, really high interparticle forces, okay? So salts, or ionic compounds are very, very hard to melt. Covalent compounds have lower melting points, and it's because, in general, they have weaker interparticle forces than ionic compounds. Ionic compounds are solids. All of them are solids. And covalent compounds are either solids, liquids, or gases based on what intermolecular forces they have. And if you remember the intermolecular forces, those are dipole-dipole, hydrogen bonding, and London dispersion forces. Of those, hydrogen bonding is the strongest. We are going to talk about the intermolecular forces at the end of this unit. And then last but not least, and probably most importantly, which we're going to talk a little bit about in a little bit more detail, is that when salts are either melted, it should also say melted here, or dissolved in water, they conduct electricity. And the next slide we're going to talk about why. Covalent compounds, when are dissolved in water, they do not conduct electricity. And I've seen multiple choice questions on the AP exam that ask you to identify, based on the properties, a compound as either ionic or covalent. And this is usually one of the property that they pick. So here we're going to discuss why ionic compounds conduct electricity when dissolved in water and not in solid form. So when ionic compounds are in solid form, we saw when we looked at the ionic crystal lattice, the ions are fixed in this lattice and cannot move. And there's lattice energy that prevents them from moving around. In order to conduct electricity, and you should write this down, you need moving ions. Okay? So when you dissolve or melt ionic compounds, the water molecules, if you're dissolving it, pull or break the lattice, and then these charges or these ions are movable, and then as a result, they can conduct electricity. But in solid form, they're not movable, so the compound cannot conduct electricity. But water, which separates the ions into positive and negative ions, we've seen that, okay, allows the charges to move or the ions to move, and then they can conduct electricity. So in our bonding unit, there are 3 types of bonds, which we talked about 2, and we're going to briefly, and only very briefly, talk about metallic bonding, and that's it for metallic bonding. So if you have a metal and a nonmetal, that's ionic bonding. If you have a nonmetal and a nonmetal bonding, that's a covalent compound, or what they call a molecular compound. And then if you have metals bonding together, that's metallic bonding. And we talked about a little bit this when we were looking at alloys, but we're going to look at the structure of a metallic bond right now, and then metallic bonding is over for the rest of the year. So in metallic bonding, the theory of bonding is called the sea of electrons theory. And that's the idea that metals are held together because they have positive nuclei, and then they have these loose valence electrons that are attracted to the positive nuclei of all the atoms, and that holds all the atoms together. And that's what that says here. So the metal is held together by the strong attractive forces between the positive nuclei, which is caused by the protons, and the valence electrons that are free moving. So there's sort of like this very strong attractive force between the positive nuclei of the metals and their valence electrons, which are floating around in sort of a sea. Now, this is sort of the only thing that we need to talk about here. The more electrons in that sea, okay, the stronger the attractions between the metal atoms and the higher the melting point. So, for example, if you have a atom, potassium, which is K, and so I can't speak, and calcium, which is Ca. So potassium has a charge of +1, and it has 1 valence electron floating around in the sea. Calcium has a charge of +2, and has 2 electrons floating around in the sea. Because calcium has more electrons in the sea, okay, there's more sort of like glue. You can think of the electrons as glue holding the metal ions together. There's more attractive forces or more electrons to be attracted to the positive nucleus. So therefore, atoms or metals with more valence electrons or more electrons in the sea tend to have stronger or higher melting points because those electrons are attracting the nucleus of the metal atoms more. All right, that's the end of the lesson. Shortest video lesson ever. See you on Friday.